Hi, and welcome to Trig Apps Day 4. Today we are talking about motion. Our understanding goal is to use sign interpretation and speed to help us find the total distance traveled by a particle. Motion of a particle in a straight line. Velocity and acceleration functions. So, if a particle P moves in a straight line, and its position is given by the displacement function s of t equals s of t, and t is greater than or equal to 0, then the velocity of p at time t is given by v of t equals s prime of t, which is the derivative of the displacement function. The acceleration of p at time t is given by a of t equals v prime of t, or s double prime of t. So it's the derivative of the velocity function. So s of 0, v of 0, and a of 0 gives us the position, the velocity, and the acceleration of the particle at time equals t at time is t equals 0. And these are all called initial conditions. So we have sign interpretation. Suppose a particle P moves in a straight line with a displacement function s of t relative to the origin L. Its velocity function is v of t and acceleration function is a of t. We can use sign diagrams to interpret where the particle is located relative to the origin, the direction of motion and where a change of direction occurs, and when the particle's velocity is increasing or decreasing. So, s of t, remember, is our displacement. Or our position. If s of t is equal to 0, p is at the origin. If it's greater than 0, p is to the right of the origin. And if it's less than 0, p is to the left of 0. And then we have signs of v of t, and v of t is our velocity. So if v of t is equal to 0, p is instantaneously at rest. If v of t is greater than 0, p is moving to the right. And if it's less than 0, p is moving to the left. And then we have signs of a of t, which is our acceleration. And if a of t is greater than 0, the velocity is increasing. If it is less than 0, velocity is decreasing. If it is equal to 0, the velocity may be a max or a min. a maximum, or a minimum. Okay. So we have this table here. And if you see these phrases used in a question, this is what you would do with them. We have initial conditions. And that would mean that time is 0. At the origin. Well, it's at the origin if s of t is equal to 0. It is stationary if v is equal to 0. It reverses if v is equal to 0. We see maximum height again, v is equal to 0. If we have a constant velocity, then a is equal to 0, and a max or minimum velocity, then a is equal to 0. Going back to our maximum height here, when a particle reverses direction, its velocity must change signs. So we need a sign diagram of a, which is our acceleration, to determine if the point is at a max or a min. All right. So now we have speed. As we have seen, velocities have size or magnitudes and a sign, which is a direction. In contrast, the speed of an object is the measure of how fast it is traveling, regardless of the direction of travel. I kind of double typed here. Speed is therefore a scalar quantity which has size but no sign. Speed cannot be negative. The speed at any instant is the magnitude of the object velocity. If s of t represents, that's supposed to be speed, not sped, then we write s equals the absolute value of v. To determine when the speed of an object is increasing or decreasing, we need to employ a sign test. If the signs of v of t and a of t are the same, then the speed of p is increasing. If the signs of v of t and a of t are opposite, then the speed of p is decreasing. So, in this case here, they're both positive or both negative. And in this case, one is positive and one is negative. And it doesn't matter which it is. So what exactly does all that crazy stuff mean? Well, let's try a problem. A particle moves in a straight line with a positive, that's supposed to be a position, sorry, wow. Position relative to some origin O, given by S of t equals t cubed minus 3t plus 1 centimeters, where t is the time in seconds, and t is greater than or equal to 0. Find expressions for the particle's velocity and acceleration and draw sign diagrams for each of them. Well, if S of t is equal to t cubed minus 3t plus 1, I need to find the velocity. So v of t is just the derivative of s of t, and that would be 3t squared minus 3 centimeters per second squared. And then a of t is the second derivative, or the derivative of v of t, and that's 6t centimeters per second squared. So if I draw a sign diagram for v of t, I need to figure out when my derivative is 0. So let's see here. I'm going to factor that. So that's 3 times t plus 1, t minus 1. So t is equal to negative 1, and t is equal to 1. But the original problem tells us that our t is greater than or equal to 0, so I don't care about the negative 1. I just need to worry about 1. Now, if I put a number between 0 and 1 into v of t, would my value be positive or negative? Well, let's see here. If we took a half and we squared it, we'd get a fourth, times 3 would be 3/4, minus 3 would be a negative number. So this would be negative. If I take a number greater than 1, and it doesn't matter what number it is, so let's use a whole number instead of a fraction. Let's try 2. 2 squared is 4. 4 times 3 is 12. 12 minus 3 is positive, so that is plus. We have to do the same thing with a of t. And just to kind of help me here, keep my number line the same. If I put in a number between 0 and 1, like a half, 6 times a half is 3, it's positive. If I put a number greater than 1, like 2, 6 times 2 is 12, it's positive. Okay, so that gives us our sign diagram. For part B, it says find the initial conditions with an S, and hence describe the motion at this instant. Well, at t equals 0, my initial position, S of 0, if I put 0 into t in the original function, I would get 1, and that would be 1 centimeter. If I do v of 0, my velocity function, if I put 0 in, I would get negative 3 centimeters per second. And if I find a of 0, I would get 0 centimeters per second squared. And then describe the motion at that instant. So therefore, the particle is 1 centimeter to the right of the origin, and it is moving left at 3 centimeters per second. That came from right here, this negative 3. The negative means I'm moving to the left. Okay? For letter C, describe the motion of the particle at t equals 2 seconds. Well, t is equal to 2, then s of 2, I put in 2 into the original function, I will get 3 centimeters. If I find v of 2, I will get 9 centimeters per second. And if I find a of 2, I will get 12 centimeters per second squared. And then let's describe it. Therefore, the particle is 3 centimeters to the right of the origin, moving to the right at 9 centimeters per second, and my speed is increasing. And my speed is increasing because in my sign diagram, v of t and a of t after 1 are both positive. If I look back up here, v of t and a of t after 1, and my time is at 2, are both positive. And when my signs are the same, that means my speed is increasing. between 0 and 1, my speed is actually decreasing because my signs are different. So D, find the position of the particle when changes in direction occur. So since V of t changes signs when t equals 1, it's back up on the page. A change in direction occurs at this instant. And s of 1 is equal to -1. So a particle the particle changes direction when it is 1 centimeter to the left of 0. So then E says to draw a motion diagram for the particle. Okay, so for all that information we just did up above, we have talked about these values, -1, 0, 1, and 3. And when time is equal to 0, let's see here. So when time is equal to 0, my position was at 1. When time is equal to 1, my position was at -1. And when time is equal to 2, we were back at 3. So what's going to happen is, that is what my diagram looks like. I'm at 1. Sorry, when t is equal to 0, I'm at 1. That goes back up to part B. When t is equal to 0, I'm at 1 centimeter. And I'm moving to the left. When t is equal to 1, okay, I'm going to change directions. So at -1, I change directions. And then when time is equal to 2, I'm at 3, and I'm moving to the right. Okay, so that's how I get this diagram. I'm here, I turn directions, and then I go on. F. For what time interval or intervals is the particle speed increasing? Well, the speed is only increasing, we already said, when t is greater than or equal to 1, and that's because v of t and a of t have the same sign. And then finally, part G is, what is the total distance traveled in the time from t equals 0 to t equals 2 seconds? Well, my total distance traveled if you look at the diagram, when t is equal to 0 to t is equal to 1, times 0 to time 1, I went from 1 to negative 1. And I'm moving left. When I'm moving left, I went 2 units. Plus, let's see here. There goes my dog I told you about. When I go from t equals 1 to t equals 2, I'm going from negative 1 to 3, so that's 4 units. And our distance is actually centimeters, so 2 plus 4 is 6 centimeters.